In this video, we'll be looking at how to use decimals in processes such as estimation and approximation, and also how we use them in addition, subtraction, multiplication, and division. Let's remind ourselves of the place values of this number, which is 7,654,321. Let's look at the place values after the decimal point. Here we have 0.1234567. If you notice the way I've read that, you'll have heard I didn't register the place values when reading these numbers off. The reason being that the place values refer to what the denominator would be if that place value would be taken on its own as a fraction. For instance, the 3 stands for 3/1000ths. Now, if I was to round this number to 3 decimal places, I would find the third decimal place, which is a 3, and then refer to the fourth to see if it will remain as 3 or round it up to 4. As I'm rounding this to 3 decimal places, I underline the 3 and then look to the next number to the right, which is 4. As it's 4 or less, the 3 stays as it is and we can rewrite it as 0.123, and that's rounded to 3 decimal places. As it's now rounded to 3 decimal places, I'll remove all the digits to the right as they're no longer relevant after the rounding. Another term often used when rounding is significant figures. This refers to figures on both sides of the decimal point, as you take the most significant figure being that first integer greater than 0 moving from left to right. If I was to round this number to 4 significant figures, I'd locate the fourth significant figure, which is a 4, and refer to the next digit to the right to see if the 4 would go up to 5 or stay as 4. As the next digit is 5, the 4 is rounded up to 5 and all the digits to the right are removed. And we end up with 0.1235. Next, we'll talk about estimation and approximation, as these mean very much the same thing in operations for GCSE Maths. When asked to estimate, either to check your answer or to calculate something complex without a calculator, we always round numbers to one significant figure. Rather than wait until the end, we'll do it at the start to all the numbers that are being used in the problem. It's worth knowing that this is a skill that you're certain to use in real life, whatever profession or career you choose. For instance, if we have this problem of getting an estimated answer for 3.25 times 0.0467, all divided by 0.1, we would round these figures to 3 times 0.05. So we have 3 times 0.05 all over 0.1, which didn't get rounded because the digit 1 is the first significant figure. We can then times 3 by the 0.05, which will give us 0.15 over 0.1, and 0.15 divided by 0.1 is 1.5. If you use a calculator, the actual answer is 1.51775, which shows how useful estimation can be when checking your answer. What we're going to look at now is how decimals affect addition and subtraction. What we find is, whilst it does have a decimal place, it doesn't affect the process very much at all. We can still use the same method as we've done before, but this time we actually have decimal points to line up. In this problem we have 21.7 plus 3.4. Whereas before we just assumed the decimal point was to the right of the units digit, now we can line it up. So we place the 21.7 above and the 3.4 underneath it. 7 plus 4 will give us 11, so we write 1 underneath and carry the 1. 1 plus 3 plus 1 would give us 5, and then 2 plus 0 would give us 2. As you can see, I've transferred the decimal point down into the answer and it gives us the answer of 25.1. In this next problem, we have 21.7 take away 3.4. So we place the 21.7 above and the 3.4 underneath. 7 take away the 4 would give us 3. We can't take away 3 from the 1, so we borrow from the tens column and we make it 11. 11 take away 3 is 8, and then 1 take away nothing gives us 1. That gives us the answer of 18.3. As you can see, I've transferred the decimal point down into the answer. Next, we'll look at how decimals affect the outcome of multiplication. So here we've got 21.7 times 3.4. We'll write the 3.4 underneath so it means less work. Now we're going to proceed like the decimal places aren't there. So we'll do 4 times 7 would give us 28, so we write the 8 here and we carry the 2. 4 times 1 would give us 4, plus 2 would give us 6, so we'll write that underneath the 3. Then 4 times 2 would give us 8, and we write that directly underneath the 2. Now we're going to move over to the tens column. Now we've got to remember that we're going to consider this to be 30. So we're going to write a 0 underneath that first 8, and then we'll carry on multiplying the rest of the number across. 3 times 7 would give us 21, so we'll write the 1 under the 6, and we'll put the 2 above the other 1. 3 times 1 would give us 3, plus the 2 would give us 5, we'll write that under the 8, and then lastly 3 times 2 would give us 6, and I'll write that in the thousands column. So now we can add these two numbers up, 868 plus 6,510. 8 plus 0 is 8, 6 plus 1 is 7, 8 plus 5 is 13, so the 3, carry the 1, 6 plus 1 would give us 7. So I have 7,378. But looking at the original numbers that we used, we lost one decimal place because it's 21.7, and we lost one decimal place in the 3.4. So we need to remove two decimal places from our final answer. And we'll do that at the bottom here, which gives us the final answer of 73.78. And we can write that as the answer to our problem. Now let's see what we can do when using decimals in the grid method. Here, we're going to remove all the decimal places and treat the problem like it's 217 times 34. So if we remove those two decimal places, we'll write a note of that up here in the left-hand corner. Now we can treat it like 217 times 34. So we'll put 200, 10 and 7, and then 30 and 4 down the left-hand side. We can now multiply these to fill in the boxes in the grids. So 30 times 200 would give us 6,000, or 2 times 3 would give us 6, followed by the 3 zeros. 10 times 30 would give us 300. 7 times 30 would give us 210. On to the next row. 200 times 4 would give us 800. 10 times 4 will give us 40. And 7 times 4 would give us 28. We can now add these down and get the answers of 238, 340, 6,800. We can now write these across here, 238, 340, 6,800, making sure we've lined up all the correct place values, and we can add these down. 0, 0 and 8 will give us 8, 0, 4 and 3 will give us 7, 8, 3 and 2 would give us 13, we'll write the 3 here, carry the 1, 6 plus 1 would give us 7. So I have 7,378. What we need to do is we need to move the two decimal places back in that we removed from the original question. And we're moving them in from the right-hand side. So we'll go in two places, put our decimal point in to give us 73.78, which is the answer to our problem. Finally, when using the lattice method, we can place the numbers, including the decimal points, into our grid. So we have 21.7 times 3.4. We can write this in, including the decimal points, into the lattice grid. So we have 2, 1.7, 3.4. And we can now multiply these across to fill in the grid. 7 times 3 would give us 21. 1 times 3 would give us 0.3. 2 times 3 would give us 0.6. On to the next row, 7 times 4 would give us 28. 1 times 4 would give us 0.4, and 2 times 4 would give us 0.8. We can now add these up using the diagonals. So 8 is on its own, will give us 8. 1 plus 2 plus 4 will give us 7. 2 plus 3 plus 8 would give us 13, so we'll write the 3 here and carry the 1 across to the next column. 6 plus 1 would give us 7. So we have 7,378. Now the decimal points, we can find out where that goes by looking at the line that the decimal points is on. If we look at the diagonal that they meet, we can then follow that across to the bottom and we end up with the decimal point just there between the 3 and the 7. We end up with 73.78 once again. So this is our answer to the problem, 73.78. Now we'll look at how to use decimals in short division. Here we have 12.096 divided by 7. Again, the 12.096 goes under the bus stop and the 7 goes outside to the left-hand side. So now we need to think how many 7s go into 1, which is 0, so we'll carry the 1 across to make 12. How many 7s go into 12? Well, that would be 1. We've got a remainder of 5. Notice how we've put the decimal point up above, directly above where it was in the actual number. How many 7s go into 50? Would be 7, with a remainder of 1. How many 7s into 19 would be 2, with a remainder of 5. And then finally, how many 7s go into 56 would be 8 with nothing left over. This means that our answer is 1.728, and we can write that in here. Next, we'll do 1.82 divided by 5. Again, the 1.82 will go underneath the bus stop, and the 5 will go outside. Notice that the decimal point is moving straight up to be reflected in the answer. How many 5s go into 1 would be 0, and we carry the 1 across. Now, how many 5s go into 18 will be 3, with 3 left over. How many 5s in 32 would be 6, with 2 left over. And then how many 5s in 25 would be 5. So we're left with the answer of 0.365, and we can write that in here. Next, we'll look at what happens with a decimal outside the bus stop. Remember the estimation answer of 0.15 divided by 0.1 from the estimation problem. Let's place that in the bus stop and see how we deal with it. So in order to divide by a decimal, the simplest way of dealing with that is by removing the decimals by multiplying it by whatever unit of 10 is going to remove the decimal point. Here, as we've only got 0.1, we only need to move one decimal place, so we're going to times it by 10. However, if we're going to times that part of the equation by 10, we need to times the other part of the equation by 10. So that gives us 0.15 times by 10 gives us 1.5. We can now write that under the bus stop and 1 outside it. How many 1s go into 1? 1. We move the decimal point up. How many 1s go into 5? 5. So we get the answer of 1.5. Lastly, let's do one more with a decimal outside the bus stop to check how the process works. Here we have 726 divided by 0.3. So as we need to deal with the one decimal place in the 0.3, we can times both inside and outside by 10. We're then going to place 7,260 inside the bus stop and 3 outside. So how many 3s go into 7 would be 2 with a remainder of 1. How many 3s into 12 would be 4 with nothing left over. How many 3s go into 6 would be 2. And don't forget how many 3s would go into 0, which would be 0. So we get the answer of 2,420, and we can write that in here. So having completed this video, it should have helped you to understand place value and rounding with decimals. Also, how to go about estimating or approximating an answer to a question. Remember, always start the problem with rounding everything to one significant figure. Also, we looked at how decimals are used in addition, subtraction, multiplication and division. In the next video, we'll be looking at percentages and how to use them in operations. I'll see you then.